Hello guys, this is Damascan from Skill Lab, and now we will see beam analysis. Ultimately we will try to find out the shear force and the bending moment diagram using SOLIDWORKS. So stay with me and I hope you're going to enjoy the video. So our today's beam is Scout. This is our today's beam. It's not as complicated as it seems. Like we have point A here, we have point B, and we have point C. From A to B is 2 meters, from B to C is 3 meters. And as you can see, from A to B we have a uniformly distributed load which is 2000 Newton per meter. And here we have non-uniformly distributed load from B up to C. Here it was 4 kilonewton per meter. At B it's 2, right? So the trick is right here. What we will do is we will go to SolidWorks and we will take point C as origin, and we will tell SolidWorks at point C you have 4 kilonewton per meter, and at point B you have 2 kilonewton. So he will automatically know the load is not uniformly distributed, and we will tell him through what we call table distribution. So the other thing is at this origin, this is 0 meter, the distance, and here at this the distance is what? Up to this 3 meter, right? 3 meter. So we will tell this SolidWorks and we're going to make the simulation and come up with shear force and bending moment diagram. So stay with me and I hope you will enjoy this video. So let's go. So open SolidWorks, File, New, Part, Sketch. Let's select from, but before that, as you can see, this is in inch, so we have to change this into meter. Sketch, our dimensions are given in meter. So we have 2 lines, right? 1, 2. What I mean is here we have point A up to B, 1 line, B up to C, another line. So let's give this dimension. Okay, so the first one was 2 meter, the second one 3 meter. So this one is 2 meter and this one is 3 meter. So let's exit this and let's go to weldment. If you don't see this tab in your computer, you can just right click here and you can click tabs. As you scroll down, you will find out the weldment part. So let's go to structural number. Let's select this. Let's right click. We don't need this. In order to find out the shear and the bending moment diagram, we don't need this kind of structure. Let's just create our own. We don't care about the size even. So let's go from this center, this beam. Okay, so now as you can see, this is the beam that we have with 2 lines or with 2 parts. If you make it normal too, we are going to apply the load from the above, from this. So we need, this one is X, this one is not X, right? It is Z. So it's better to change it into Y. There is no, the reason behind this is to avoid confusion after when we find out the force. No another reason. We don't have another kind of reason for this. We just want to make it in the Y and in the X direction. So let's go to edit feature and let's rotate this 90 degrees. Now you can check it. You can check this thing. You got this in Y and X. Okay, so let's go to simulation. And if you don't find the simulation part, you can go SolidWorks add-ins, and when you click this, it will immediately appear right to SolidWorks add-ins, the simulation. So new study. Let's say this beam analysis 8. As we always do, let's assign the material. In manual calculation, we don't need a material, but here there is no difference in the calculation. But the thing is, SolidWorks, if SolidWorks is going to proceed to the simulation part, it it's must to assign a material for the beam that we are working, that we are making analysis. Let's apply, close, and let's go to fixtures, fix the geometry. So here the fixed part this side, like in the longer side or at point C. It means right to right. I think this one is the longest part. Okay, this one. So let's select this. Let's increase the size of the symbols. Let's make them 500. And yeah, this is our beam. Click. We're done with this one. So let's apply the load. This is the first load. From A to B, we have 2 kilonewton per meter, which is uniformly distributed, right? So let's make this. Or let's go to loads, force, and let's select the beam, this beam, and it's gonna be along the front plane, this plane. So per unit length, as you can see, this one is Newton per meter. Our given dimension is in 2 kilonewton per meter. So we should change this thing to Newton per meter, which is 2000, right? 2000 Newton per meter. So let's increase and let's see the direction of this force. As you can see, it's in upward, so the given force downward. You can just simply click reverse direction. Here we go. Simple. Let's carry on. And the next load is this one. Like, I want you to focus to stay with me here. We're going to make it simple. We have 4 at this point and at this point. So let's go to external loads, force. Let's choose this. And along the front plane, it's non-uniform distribution load, right? This one is, as you can see, load distribution, so we should change this table driven. And this one is also percentage, so we're going to give him a distance by assigning the origin, so we make this distance. So at this 0 distance, as you can see, at this point, at C, it was 4, right? So let's make this 4, which means this is in Newton per meter, but this one is in kilonewton per meter, so we make this one 4000, right? Let's go. And the next point is at this, it was 3 meter. 3 meter into point B, we have how much? 2000, right? Which is equal to this point, right? Uniform distributed. So we have here 2 kilonewton, we have here 4 kilonewton. Then it starts decreasing from 4 up to 2, which means from point C to point B. So what we'll do is, let's see, as you can see, the directional force in the wrong way, right? So let's go and change this thing. Let's make this, and let's change this. But still, we don't need this force to be in this direction. We need them to be upward, in the upward side, and their direction will be downward. So let's just make this minus or negative 2000, and this negative 4000. Okay, so what else do we left? Yeah, but still our force is not like this. So let's flip this out. Like, as you can see, the maximum force is here, but here the maximum force is at point B. So in order to solve this thing, you can just flip this origin simply. You got it, right? So to make it visible, let's go and increase the size 500. We're done. It was simple, right? The thing is this one. You go here and you select this thing, non-uniform distribution, and this thing was load distribution, so you change it to table driven, and you can change this percentage into distance. After that, we have a distance here, we have force per unit length or Newton per meter, so you can specify at any length that you want any kind of non-uniformly distributed load, and you can just flip the origin, and you can see the beam length that we are applying non-uniform load is how much? 3 meter. as you can see here, it is 3 meter. So let's save this thing, and now we only left with one thing, right? Here is run the study. So let's see the reaction forces first. You can see, but before that, let's see the beam diagrams. So shear force, let's make this 100, and chart options, show maximum. You can extend this thing like this, and let's make this floating, and this thing 1. This is right. So as you can see, we have 13. So this is the shear force diagram. The sign is all about sign convention, or you can say it like this, right? This. So what about the bending moment diagram? So let's go and make this floating, and this one. So here we go, guys. You got me right. So you have this 28, and here we have 20. Still, it's all about what? Sign convention. So we got this. So in order to see it into, you can right click here, results. You can go to compare results, and you can check the thing that you want, and you can click this one. So this names our work, right? Here we have this one, and here we have this one. Or if you want to, so you can exit this. You can go Windows, this one is what? Okay, I want this. Yeah. So you can make like this. Twin it right. And this one is like this. Yeah, I hope it's clear, and thank you for your time, and we will come up with another video, and we'll try to help you as much as we can with this kind of analysis. We'll not only work about beam, we'll go to column, we'll work truss, and we'll also work about the thermal analysis of materials for the next week. So stay with us, and don't forget to subscribe. Bye bye.